modeling with equation. We talk about the interest rate problem first. Here we have the formula. The interest is equal to the principal times the rate times time. So here in this formula, I represent the interest, P represents the principal. The principal is the amount of money that invested or loan. R is the interest rate, and we will write this in terms of decimal. T is the time in year. Let's take a look at the first example. Mary inherited 100,000 and invested into two savings accounts. One account pays 6% interest and the other is 4%. If Mary's total interest is $5,025 per year, how much money is invested at each rate? Well, let's start out by defining our variable. Let X be the amount of money invested in the account that earn 6% interest. So she has $100,000 in total. She invests part of that amount of money into the account that earns 6% interest. Then the amount of money that is left over is being invested in the account that earns 4% interest. The amount of money that left over is equal to the total amount of money minus the money that invests in the 6% interest. So now 100,000 minus X is the amount of money that invests in the account that earns 4% interest. Okay. So let's talk about the interest earned in account number 1. After 1 year. Well, the interest earned equal to the interest rate times the amount of money invested in that account. Then the interest earned in account number 2 after 1 year is equal to the interest rate times the amount of money that invested in that account. We were told that the total interest is $5,025. Then I can write my equation as the interest earned in one of the account plus the interest earned in the other account have to equal the total interest earned. Let's solve this equation. So then the amount of money that invested in the account that earns 6% interest is $51,250. And the amount that is in the account that earns 4% is the difference, the leftover. We can use this type of formulas to apply this to this kind of mixture problem. So let's see how do we do that. A manufacturer of soft drink advertised the orange soda as natural flavor, although it contained only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% of the fruit juice. How much pure orange juice must this manufacturer add to 900 gallons of orange soda to confirm the new regulation? We will first identify a variable for this problem. So here the question says how much pure orange juice must this manufacturer add to 900 gallons of orange soda to comfort from the new regulation. So we will let X be the amount of orange juice be added. So here, let's start with this. The manufacturer of soft drink advertised the orange soda as natural flavor, although it only contains 5% orange juice. Okay. Let's start with the original amount of orange juice. That is 900 gallons. That contain 5% orange juice. Now we need to add actual orange juice, that X amount in, to create a mixture that is conform to the new regulation. Okay. And since we add X amount of orange juice, well, orange juice have 100% orange juice. Right? The new mixture have 10% orange juice. So when we add the orange juice into 900 gallons, the end mixture will be 900 plus X. Okay. We solve this problem based on the amount of orange juice. There is 5% orange juice in 900 gallons. We plus X amount of orange juice to get 10% of orange juice in the end mixture. We can solve this equation. So we have to add 50 gallons of orange juice into 900 gallons of orange juice of 5% orange juice in order to make it comply to the new regulation. Let's take a look at the next problem. A merchant blend tea that sells $3 an ounce with tea that sells $2.75 an ounce to produce an 80 ounce of mixture that sells for $2.90 an ounce. How many ounces of each type of tea does the merchant use in the blend? Okay, so let's start with let X be the amount of tea that costs $3 per ounce. Note that when you add two mixtures in and it creates 80 ounces in total, this means if the first one is X, then 80 minus X will be the amount of tea that costs $2.70 per ounce. Okay. Now, we solve this problem based on the cost of each of the type of tea. Okay, so then the cost of tea that sell for $3 an ounce is equal to $3 times X. The cost of tea that sell for $2.75 per ounce is equal to 2.75 times 80 minus X. Together, it creates a mixture. That will sell for $2.90 per ounce. So this equal to 80 times 2.90. Well, since you add two things to create a mixture, now we can see the equation come out handy. That is the tea that costs $3 plus the cost of the tea, the total cost of tea that is sell for 2.75 cents, have to equal the cost of the whole mixture. We can solve this equation. Combine like term. Subtract 220 to both sides. Divide by 0.25. So here we have 48 ounces of tea that sell for $3 per pound per ounce, and 32 ounces of tea that sell for $2.75 per ounce. Let's move on to the next type of problem, the uniform motion. Here we have distance equal rate times time. An airplane flies 3,000 miles with the wind in 5 hours and against the wind in 6 hours. What is the speed of the wind and the speed of the airplane in still air? Okay, so first we will let X be the speed of the wind. and y be the speed of the airplane. Let's organize our information in a table. We know our formula is distance equal rate times the time. So here, in the first row, we make this flying with the plane, with the wind. And on the second row, we look at against. Both time is flying for 3,000 miles. When you fly with the plane, we add in the speed of the plane and the wind. When we fly against the plane, we subtract the speed of the wind. And here we have this is 6 hours. With the wind, we go faster, so this takes 5 hours. But going against the wind, it takes longer, so this is 6 hours. Okay. Well, in the first rows, I can come up with the equation here. I know that the distance is equal to rate times the time. Same thing happened in the second equation. I can simplify the first equation. This man here I can divide both sides by 5. So 600 equal x plus y. This means y is equal to 600 minus x. I will substitute this into my equation that I get in the second row. This means 3,000 is equal to 600 minus x times 6. I can divide both sides of this equation by 6. So 500 is equal to 600 minus 2x. I subtract both sides by 600, so negative 100 is equal to negative 2x. So x here equal to 50. If x equal to 50, so here I have the speed of the wind. Equal x equal 50 miles per hour. Well, the speed of the plane I know that x plus y equals 600. So y equal to 600 minus x equals 600 minus 50, 550 miles per hour. Okay. In the next problem, Wendy took a trip from Davenport to Omaha, a distance of 300 miles. She traveled part of the way by bus, which arrived at the train station just in time for Wendy to complete the journey by train. The bus averaged 40 miles per hour, and the train averaged 60 miles per hour. She made it to her destination after 5.5 hours. How long did she spend on the train? Okay, so let x be the time spent on the train. organize my information in the table again, distance equal rate times time. Start with bus and train. So what do I know? Wendy took a trip from Davenport to Omaha, a total distance of 300 miles. So the 300 mile is the distance that traveled by bus plus the distance that traveled by train. The bus averaged 40 miles per hour. The train averaged 660 miles per hour, and she make it to her destination after 5.5 hours. So X is the amount of time that's spent on the train. If the total time travel is 5.5 hours, then the time spent on the bus will be 5.5 hours minus X. So I can say, from here, I can create my equation. The distance equal rate times time. So the distance traveled by bus is 40 times 5.5 minus X. The distance traveled by train is 60X. The total distance traveled by bus and train total to be 300. So 40 times 5.5 minus X plus 60X equals 300. We can solve this equation. So here we can see that, well, she spent 4 hours on the train. And 1.5 hours on bus. Station.